Alright, welcome back to Learning with Merit. Today we're going to talk about Python functions, and specifically we're going to look at function definition, Python indentation, and the code blocks that we need for function definition. We're going to talk about calling functions, returning values in functions, parameters, arguments, and then functions with conditionals, while loops, and for loops as a few examples. First thing we need to remember is that we are talking about sequential programming right now, or a program that executes from top to bottom and left to right. Functions help us simplify our code, especially as they become more and more complex. So first things first, let's talk about function definition. This is teaching the computer how to perform a function. So we'll come down here. The first thing we do is we write the def keyword. This is to indicate that we are defining a function. You'll notice that there is no indentation there. Then we give the function a name. In this case, we'll just use a generic function name as function name. Then we add parentheses and a colon. Then the next line should be indented. This will be our code block. In this case, we might say print hello world. If I run this, you'll notice that it does not output anything. That's because we have just taught the computer how to perform the function name function, but we haven't told it to perform it yet. This is where we call it. So we say function underscore name, open and close parentheses like that. Now if we run it, we see hello world. And that is because we've told it to actually run the function this time. So let's break this down a little bit. Here we have our function definition, so def function name parentheses colon. We indent two spaces to be a part of the function block. Then we have our code, and then we unindent to exit the function definition and go back to the other code. Another way that we can look at this is to draw a code block like this. So here we have the whole block, and inside here is the function definition. And that just gives us a little bit of a visual that will help us understand what's going on. Now, whenever we need to call the function, so let's look at calling a function. Clear this out, exit. So we have the name, we have the code block idea here. Let's come down here. Talk about function calling. So this is telling the computer to perform the function, okay, or a particular function. One you're very familiar with, hopefully by this point, is the print function. This is us calling the print function. We use its name and then open and close parentheses. Another one that we may have used in the past is called the length function. All of the casting functions, int is a function. Float is a function, like that. These are all functions, and how do we know? They have a specific name, and then they have open and close parentheses. For our function, called function name, we would write its name and then open close parentheses. So we'll add this in here so we can see it as a note. We call this, awkwardly enough, the caller. So this is the caller for the function, or us calling the function. It is important to note and remember that functions must be defined before they are called. If I create a function after I call it, it will not work. You will receive an error. We can actually take a look at this. So if I say def and I say print word, and then I tell it to print hello. If I call it afterwards, so I say print word like that, I will get some output. It output the word hello. However, if I take this, I stick it above it, now when I hit run, I get an error, and it says print word is not defined. So it has no idea what the function is supposed to do. if you define it after you have called it. Clear that out. So now we'll come down a little further. So there is our caller. So far all we've done is printed something out. But let's talk about the return keyword now. So sometimes we want functions to bring back values to us. So we're actually going to call our newest function here, bring back. Once I get it pulled up here. So here we have the def keyword, and we have given the name bring back to our function. You'll notice open and close parentheses again, and a colon. Then we've indented 2 spaces, and now we have our code block. So it says return is the keyword to send a function's result back to the caller. And it says return, this is the result. Returning exits the function. So if you return in the function anywhere, you actually exit the function. So even if there's more code after the return, it still exits the function. And then here is us calling the bring back function. So we say bring back, just like that. If we use return and we want to see the output of the function call, the result, we need to put it inside of a print function. So here on the inside is our bring back function call, and it's going to bring back this is the result, and here is our print. Let's actually take a look at this. If I copy this, go to our test file here, you'll see this is the result. And that is from this right here. If we get rid of that and hit run, you see there is now no output. You stick it back, save and hit run, and there it is, back again. Just to show you, we'll add an enter here. If I told it to print something else, because returning exits the function, this right here will never run. So I'll save this, and I'll hit run. And you'll see it just says this is the result. It never prints something else. And that is because returning exits the function. So we never actually get to this line of code. There's one more thing we can do. If we look here, we can assign the value, the result, to a variable. So here we are assigning the return value to a variable. So we have bring back. It brings back this is the result. I've put that in the variable called result, and then I've printed it out. If we look at our test file, we can do the same thing. So I'm going to get rid of both of these. I'm going to paste that. And you'll see it should say this is the result at the end. So I'm going to clear my output and hit run, and you'll see this is the result. So the same thing happened. This allows me to take, let's say it was the answer to a math problem, I could stick it inside of a variable and then use that variable later. Okay? And sometimes the math function may be different. It may come with a different answer. But we know what we want to do with it, and that's why we're using a function. So now we'll clear this out and save that. So we'll see there's several different things we can do. We can just call it. Sometimes that's all you need to do. Sometimes you don't have it return. You just have it do something. Right? Then if we want to see the output, what the result is, we can just stick that inside of a print statement. Or alternatively, we can stick the result in a variable and then print that variable out if we want to do. And it all depends on what you're exactly trying to do with the problem. So now we've looked at the return values. Let's talk about parameters in a function now. So parameters specifically, they are variables okay, that are going to accept a value later. So we'll call them parameters. And they only exist inside of the function. So they are actually local variables. So here's our little definition. Parameters are variables that represent unknown values. So values you don't know. You know what you want to do with them, you just don't know what the exact values are, or maybe you want to make it so that you can use lots of different values, but they're always going to do the same thing with those values in the function. So they represent unknown values in the function definition, and they are, of course, variables. So here is a function definition for us. Whoops. Let me fix that. Hit enter a couple times. So here's a function definition for us. This one is called, so there's our DEF. This one is called accept values because it's going to accept values. The values it's going to accept are going to be represented as parameter 1 and parameter 2. These are inside of the parentheses. So you notice in the other functions we've had parentheses with nothing in them. That's because we didn't need any parameters. Now we need parameters, so we stick them inside the parentheses. And when there are multiple parameters, we separate them with a comma. Then here we're just doing something simple, printing out parameter 1 and parameter 2. Now if I call this, it looks like this. Accept values, and then I give it values. In this case, hello and world, and it should print out hello and world. So parameter 1 will be replaced with hello. Parameter 2 will be replaced with world. So let's go take a look at this in our test file. So if I hit play here, we've got hello world. We could change it to something else. We could do some text, like that if we wanted to, and you'll see some text. We could change it to numbers if we wanted, as long as we have 2. I could do 5, I could do 3. You'll notice that they're also separated by commas and they're getting printed out. But what if, for example, I just provided one argument? This will provide us with an error because it says missing one required positional arguments, parameter 2. So it expected us to give it 2 values. Speaking of arguments, let's go back and look at what arguments are. So arguments, they're going to be the actual values that we give to a function. So arguments. If we take our function that we have here, and we know that we have parameters that go with this function. Oops, I missed part of my line there. Grab it again. So if we take these 2 parameters here, whenever we actually call it, these are our arguments that we provide. So here we're calling, this is our caller right here, accept values, hello and world. Arguments are the actual values that we use when calling the function. So this time the arguments are hello and world. Multiple arguments are always separated by a comma, just like the parameters are separated by a comma. First parameter is the first argument, and the second parameter is the second argument, and so on and so forth. And you can have as many parameters as you want, and as long as the number of parameters and arguments are equal, then there shouldn't be a problem with the function. So I add this here. There must be one argument for every one parameter, or you will get an error. You also want to make sure that they are in the same order. Order does matter. You can't, put parameter 1 right here and then try to put the answer right there, put the argument right there, and say, oh, why is it not going to parameter 1? It's because you did it in the wrong order. Okay, so order does matter. Let's actually look at some examples now. So we've talked about how to define a function. You use the DEF keyword, you give it a name, open and close parentheses, and a colon. Then you indent 2 spaces and write your code block. And we've talked about the indentation, right? We need to unindent two spaces to exit that function definition. I showed you how to call a function. Use something called a caller, which is the function's name, and an open and close parentheses. Using the return keyword. Return is something we're going to bring back as a result of the function. So here we have our bring back function definition with the open and close parentheses and a colon. We use the return keyword and we tell it to return this result. Then we call it and it brings back the result at this point. Same thing here. If we want to be able to see it, we use the print keyword and it prints the result. Here we assigned the result to a variable called result, and then we printed that out. Parameters are our variables that we are going to use inside of the function and only exist inside of the function. So parameter 1 and parameter 2. Then we call the function and use the name, and then inside those parentheses we provide actual values separated by commas if necessary. Those actual values we provide are called arguments. So here we have hello, here we have world. Those are our arguments for this function call. If I added another one, I may have different arguments. So let's look at a couple of examples using conditionals, while loops, and for loops. So here's a function definition. This one is designed to check if a number is even or odd. So I call the function even or odd because we like to call functions what they do. Okay? That way we understand whenever we use them what they do. I'm going to use one parameter called num, and then I'm going to use an if statement or a conditional here. And I'm going to say if num modulo 2, which modulo 2 is getting the remainder. So even numbers will have a remainder of 0. We're going to say equals 0. So any even number would be divisible by 2 with a remainder of 0. And so that's our check. That's our Boolean expression there. Then we are going to print, if that's true, num is even. Otherwise, if we don't get the number 0 back, which means we're probably going to get the number 1 back, that means it's an odd number. So here I'll say print num is odd. So this is a simple little function to check if a number is even or odd. Then I just give it a number. And I've actually got a few numbers here for us to try. They're very simple. These are all our different function calls, and you'll notice I didn't have to rewrite it every time. So I was able to do this 4 times here without having to rewrite this entire function every single time for a different value, or having to go back and change everything. So 1, 2, 3, and 4. If I grab this, let's go stick it in our test file and run it, you'll see num is odd, num is even, num is odd, num is even. 1 is odd, 2 is even, 3 is odd, 4 is even. Let's try an even bigger number. Do even or odd, and we could just type out a random number, and we see as humans that that should be an odd number because it ends in a 1. I'll get rid of the rest of these, save it, run it. Num is odd, perfect, so the check works. And this makes it a lot simpler than having to rewrite this every time. Let's do another check. We could use a while loop. Let's do def count underscore up. This is a while loop that will allow us to count up, and I am going to use 3 parameters this time, start, stop, and step, and we're only going to count up. So here we're going to use a while loop we've used before. We're going to say count equals start while count is less than or equal to stop. We are going to print the count out and end it with just a space. Then we are going to increase count by our step with our plus equals there. And then I'm going to add a print there at the end just so that we go to a new line once we're done counting. Then I've actually got a few function calls ready for that as well. So you don't have to sit here and watch me type it. You'll see that I've unindented here, and here we're going to count up several different ways. Let's go test this. So this is our start, this is our stop, this is our step, start, stop, step, start, stop, step, start, stop, step, start, stop, step. Right? And it should be fairly simple for us. So let's see what we actually get as output. So the first one, we're supposed to count to 10, and we did. So we counted to 10 from 1 by ones. The second time, we're supposed to go from 50 to 100 by 10s, and we went from 50 to 100 by 10s. The third one, we go from 0 to 24 by 8s. We did right there. The fourth one, we go from 5 to 500 by 5s. That's this one right here. And the last one, we do 40 to 60 by 2s. And here it is right there, 40 to 60 by 2s. And that made it a lot simpler to do all that repetitive work without having to retype or go through and change start, stop, and step when we know this code should work every time. And hopefully you'll notice there's a lot of variables going on in there. There are no actual values until we get down here to the call. But I know that it's always going to work this way pretty much every time. Let's do one more. We can write a for loop. We'll call this count 4. I'm also going to use a start, a stop, and a step on this one. And I'll say for count and range, start, stop, and step. Then I'll tell it to print count, end equals. Add a print statement. You'll notice I unindented. I added a print at the end so that it goes to a new line when we're done counting. Then, just like the rest of them, I have several calls ready for that already. You'll remember that we have to add one or subtract one to stop every time to make sure that we actually go to the number we want. So if the numbers seem a little funky, that's why. So this is from 0 to 35 going down. This is from 10 to 20 going up by 2s. This is from 10 to negative 6 going up by 1s. This is from negative 5 to negative 15. Sorry, that would be negative 5. Negative 10 to negative 5 up by 1s. Negative 5 to negative 15, or to positive 15 by 5s. So take this, stick it in our test file, save, and run. Let's see what we get out. Not quite enough room here. It's going to wrap around. So we have from 0 to 35 going down by 1s. That's that right there. We have from 10 to 20 by 2s. That's that one right there. We have 10 to negative 6 by 1s. Now what you'll notice is this goes to negative 7. And if I wanted to go to negative 5, I would change it to, to negative 4 right there. You have to remember, you have to actually add 1 if you're going up and subtract 1 if you're going down. So that's why it only goes to negative 7 there. And then this one right here is the last one. So that's negative 5 to 15 by 5s. And that does exactly what we expected. So if I save this again and rerun it, there we go. Now the code on the, third one acts like I wanted it to. So it makes it a lot simpler than having to go through here and do this over and over and over, or copy and paste it. And right now, even these are fairly simple functions. Whenever you get a lot of stuff going on together, it's even more useful to have functions because it's going to be less and less work over time. So we covered defining functions, the indentation that you need, calling a function, returning values with a function, the parameters and arguments, and then a couple of examples with functions using conditionals, while loops, and for loops. Thank you for watching.